Okay, good afternoon. My name is Ivan Arraut from Tokyo University of Science. I come to talk about extension of the Nambu-Goldstone theory, specifically for non-relativistic systems. The standard Nambu-Goldstone theory basically says that you have an action which is invariant under the group G, which is the large group. The vacuum is not necessarily invariant under the action of the full group. Instead of that, it's invariant under the action of a subgroup. And the dimension of the coset, you can define a coset space, and the dimension of the coset space define the number of broken generators. And basically, the number of Nambu-Goldstone bosons is equal to the number of broken generators. This is the standard Nambu-Goldstone theory. And the condition of a spontaneous symmetry breaking is that one on the right-hand side. Basically, the commutator between the order parameter and the broken generator vacuum expectation value different from 0. So when you develop and introduce intermediate set of states and assume invariance under space-time translation, you can derive you can reach the conclusion that the momentum and the energy go simultaneously to 0, and you conclude that the dispersion relation has to be linear. What happened in non-relativistic system? Well, Murayama, Watanabe, and Browner, they have demonstrated that the number of Nambu-Goldstone bosons is not necessarily equal to the number of broken generators. The reason I will explain in a moment, but in principle, there are pair of broken generators canonically conjugate each other, and this condition has to be satisfied. If you expand in terms of intermediate set of complete states in the same footing as before, the same way as before, you realize that this condition is nothing else. Is saying that basically two broken generators generate one single degree of freedom. And this can be concluded after doing the same procedures as before. Finally, I propose a final condition. Basically, Nielsen and Chada in the past demonstrated that the dispersion relation for the Nambu-Goldstone bosons coming from canonically conjugate pairs have to be quadratic. I have realized that the conditions of Nielsen and Chada can be summarized in this statement. Basically, the commutator of the commutator. The second commutator is the matrix rho, which Murayama, Watanabe, and Browner demonstrated. In my case, I extended the spontaneous symmetry Riemann condition for including the order parameter. When you develop fully the same, you introduce intermediate set of complete states, and you do the spatial integrations and assume translational invariance on the space-time, space-time translational invariance for the charges. You reach to the conclusion that when you concentrate in the neighborhood when the momentum goes to 0, you reach to the conclusion that in fact the dispersion relation has to be quadratic. And this is the relation found by Murayama, Watanabe, and Browner. The number of broken generators minus the number of Nambu-Goldstone bosons is equal 1/2 the rank of the matrix rho. The matrix rho is defined in this way by the commutator of the canonically conjugate pairs of broken generators. Finally, at the space-time level, it's in development, but I can say that the way how I analyzing is how the different observers define the vacuum at different positions for space-time. Two observers defining the same equivalent space-time equivalent vacuums, they can be connected through a symmetry directly. But two observers defining inequivalent vacuums, they are connected through broken generators. Basically, there are many formulations of gravity which suggest that this should be correct. Still, I have time, so I can reach the conclusions. The conclusions is, in non-relativistic systems, the Nambu-Goldstone theorem is satisfied if we take into account the correction of the dimension of the coset space. What does it mean? It means that the expressions found by Murayama and colleagues is equivalent to a correction of the dimension of the coset space if you look at it closer. In some sense, is equivalent to think that part of the canonically conjugate operators become order parameters. The correction of the dimension of the coset space is directly connected with the dispersion relation corrections, as I demonstrated before. The intersection of the three conditions, namely the standard spontaneous symmetry condition, the expression found by Murayama and colleagues, and the expression proposed by me, the intersection of these three conditions gives you the appropriate dispersion relation and the appropriate number of Nambu-Goldstone bosons in non-relativistic system. But this is for internal symmetries. For space-time symmetries, it's in process. Thank you very much. That's all. Okay.